In this second session, we turn our attention to reasoning. How do we, as scholars, reason, especially from our empirical material to our theoretical conclusions? As we are sitting at our tables having a theoretical conversation with our peers, a lot of the things we say are in one way or another based on empirical material and empirical analysis. The thesis for today comes from an article I co-authored with Saku Mantere, where we wrote, while methodological texts candidly acknowledge that research is a complex endeavor beset with numerous challenges, the ability to reason rationally from one's data to a theoretical conclusion, for instance, is typically assumed to be possible. And indeed, there's something strange to me about when we speak of managerial cognition and managerial decision making. We're usually the first to point out, based on lessons from behavioral economics, that we suffer from all kinds of confirmation biases, predispositions, and such. But somehow, when we think about our own reasoning faculties, as researchers, we tend not to acknowledge those limitations as strongly, as clearly, as candidly as we do when we talk about the reasoning of others. Here are the materials on which this session will be based. And again, I have highlighted in boldface the ones I will be drawing upon more than the others. Again, I invite you to take a look at these readings, all of them, but again, don't read them as prescriptive. Read them as points of view, food for thought, not as prescription or guidance or handbooks of any kind. This is one of the sessions where we really have to make sense individually and collectively of what is it that we do when we go to work Monday morning. I have found discussions on reasoning to be very confusing in many ways in our field. And let me first start by describing my confusion and trying to make sense of where that confusion might come from. So let me introduce three different labels that we use in our field when we talk about research, and labels that make use of reasoning terminology. One is the label hypothetico-deductive research. When we use the label, it may create the misleading connotation that hypothesis testing research is somehow founded on deductive reasoning. This is not the case. There's also the label inductive case research. This may lead you to mistakenly think that theory somehow inductively emerges from our data. In fact, it does not. And finally, this is a more recent development. I've heard scholars to use the term abductive research when they talk about various types of qualitative research. And this again may mislead us to think that there's something characteristically abductive about qualitative research. Again, this is not true. So, when I speak of deduction, induction, and abduction, I speak of forms of reasoning. And when philosophers talk about deduction, induction, and abduction, they speak of forms of reasoning as well. Not ways of doing research, not research designs. And here I might give a shout out to the Stanford Encyclopedia of Philosophy. That is my go-to source on anything philosophical. It is free of charge, available online, that has entries among other things for all the reasoning terms. And if you go and take a look at SEP and its entries, you will realize that the terms deduction, induction, and abduction are used to describe forms of reasoning, not ways of doing research. And one of the things that Sakumantere and I tried to make clear in our 2013 article is that no matter what research design you use, you will make use of the three forms of reasoning: induction, deduction, and abduction. You will just use them for different purposes, but they're essentially tools. And they're tools that we all use. And that's why using these terms individually to refer to research designs is guaranteed to confuse more than clarify. Let me illustrate the three forms of reasoning by describing an analogy authored by Charles Peirce, indeed pronounced Peirce, not Pierce. Peirce was an American philosopher of science and an empirical scientist who did a lot of work back in the 1800s and early 1900s on reasoning. So, we have three statements here. Imagine that I have a bag of beans in my hand. Statement number one, all the beans in this bag are white. Then let's say that you see me reach into the bag and pull out a handful of beans. Statement number two, these beans are from this bag. And then finally, I reveal the color of the beans in my hand. The beans in my hand are white. That's statement number three. Now, to illustrate deduction, induction, and abduction, let us take any two of these premises, any two of these statements as premises, and see in what way they imply the third statement. So let's start with taking 1 and 2 as premises. All the beans in this bag are white. You see me reach into the bag. What do you think the color of the beans in my hand is going to be? Well, you can bet your life savings that those beans are going to be white. Why is that? Because 1 and 2 deductively imply 3. And this is the hallmark of deductive reasoning. The conclusion is logically entailed, if you will, in the premises. And deduction is sometimes called truth-preserving form of reasoning because it means that if 1 and 2 are true, then 3 is going to be true as well. Because 1 and 2 logically imply, without any uncertainty, without any doubt, the conclusion, number 3. But this means that when we use deductive reasoning, we have to be careful with the kinds of premises that we introduce. Because if we introduce false premises, then the conclusion may be false as well. So this notion of truth preserving cuts both ways. Now, next, let's take 2 and 3 and see in what way they imply 1. So, I have a bag of beans in my hand. I reach into the bag and I show you a handful of white beans. Can we infer that all the beans in the bag are white? Well, we can, but it's no longer a deductive inference. It's a generalization. So let's say that there are 100 beans in the bag and I just pulled out 20 and they're all white. Well, if I make the inference that the remaining 80 are white as well, then I'm making an empirical generalization, and this is inductive reasoning. And you could actually do the math. If there are 100 beans in the bag and I randomly pick 20 and they're all white, you could probably come up with the probability that expresses our confidence of all the beans in the bag being white. So now we're talking about probabilities. So whereas deduction either is or isn't coherent. Deduction doesn't subscribe to degrees. Induction does. We have weaker inductions and we have stronger inductions. And anyone who does statistical research knows that we are able to do stronger inductive inferences when we have larger samples. we use the word probably or likely, highly likely. So, to express the degree of strength in the induction. Induction and deduction are terms that you've probably heard before. The third one you may have heard of, but let me nonetheless tread carefully here. Let's take 1 and 3 and see in what way they imply 2. So, I have a bag of white beans in my hand, and in my other hand I have a stack of white beans. And now the question is, did these beans come out of this bag? Now there's really no, if I asked you what's the probability that they came out of the bag, there's really no probability. How would you do the math to begin with? So there is no probability calculus the same way there is in the case of inductive reasoning. But if I have a bag of white beans in one hand and a stack of white beans in another, it seems reasonable that these beans came out of this bag. And indeed, we often infer, it's plausible. Let me make a distinction between the word probably and plausibly. When I say something is plausible, I'm just saying that it could be the case that. But there's really no probability. Again, there's no way we could do the math on the probability. But we can abductively infer that the white beans in my hand came from a bag of white beans in my other hand. As you can see, I've used different colors for deduction, induction, and abduction. Deduction is black, induction is dark gray, and then abduction is light gray. This is to demonstrate that abduction is logically, from a logical point of view, the weakest form of reasoning. In fact, if you think about it, abductive reasoning is really close to the fallacy of affirming the consequent. That said, we all use abductive reasoning all the time to make sense, to answer questions, to create explanations. So, if the question is, why are the beans in my hand white? The explanation is, well, because they came from a bag full of white beans. Now, Saku Mantere and I discussed the beans in the bag example in our 2013 AMR article, where we invite the reader to think of this metaphorically. Think of the bags as our theories. We always have multiple bags, multiple theories. And then think of the beans and their colors as our data. And data are something that we want to explain, something that we want to interpret. And now, the theoretical interpretation or explanation for an observation is based on abductive reasoning, because number 2 here, a statement is analogous with an explanation. And it's really important not to confound induction and abduction. There are 2 different forms of reasoning aimed at different ends. Induction typically involves a generalization of some kind. I mean, there are subcategories of induction, most notably enumerative induction and eliminative induction. And there are also many variants of abductive reasoning. But the difference between the 2 is that whereas induction is an inference to a generalization of some kind, we go from the particular to the general. Abduction is different. Abduction offers sense-making, interpretation, explanation. And this is why understanding abductive reasoning is so important, because out of the 3 forms of reasoning, It's the only form that helps us formulate explanations. Here's an exercise I do with doctoral students who take the seminar. I show them this photograph and then, without any more instructions, put them into small groups and ask them, what's going on in this picture? How do you make sense of what you see here? We see a police car, an ambulance, a couple pedestrians, and a guy on a bike. What's happened? What's the explanation? And as you might imagine, students come back with different kinds of plausible explanations. Someone's hurt, maybe a crime has been committed, maybe nothing is going on. As we're trying to make sense of what's going on in this photograph, we're engaging in abductive reasoning. We're looking at various clues. We consider some aspects relevant and others irrelevant. Most of us will probably consider the ambulance and the police car with the lights flashing as relevant material. Maybe the guy on a bike isn't relevant, or the brand of his shoes, they look like Nikes. Maybe that's irrelevant. So we're filtering based on what we consider relevant. And it probably shouldn't come as a surprise that different people will find different aspects relevant. For instance, if you look closely, this looks like it's the corner of 48th Street and 9th Avenue in New York City. Is that relevant? Some may find it relevant. If you do, then you would have to convince your audience. Again, you're trying to convince an audience of your interpretation. Or is it relevant that this is the United States and the state of New York? Well, having lived in New York and also having lived in Finland, Spain, and a couple other countries, one of the things I always noticed about the US was that the cops would always show up. Even if someone was just hurt and needed an ambulance, the law enforcement would show up. This doesn't happen in all countries. Okay, so maybe the fact that this is in New York City, maybe the specific street corner isn't relevant, but maybe the fact that this is the United States and the state of New York, maybe the interpretation we give to the police car is different than if this were, say, Helsinki, Finland. Another thing that someone who is familiar with the city of New York, there is another car right in front of the police car. You can't quite see what it is, but it's actually another ambulance. And the way you can tell is there is a logo at the back of that truck that looks like the logo of the Mount Sinai Hospital. And indeed, that is another ambulance. Now, those of us who don't recognize the logo of the Mount Sinai Hospital would probably pay no attention to the other ambulance. But there are, in fact, two ambulances here. This is abductive reasoning. It is in many ways subjective, experience-based, and a cognitive form of reasoning. And everyone's cognition is at least in part idiosyncratic, so is abductive reasoning. This doesn't mean that anything goes. Recall, you're trying to convince an audience here. So you have to, however you conduct your reasoning, you have to make it credible in the eyes of your audience. Another thing that is characteristic of abductive reasoning is that it's often comparative. And students would find out very quickly as they are talking about this in small groups that there are multiple options. And they somehow have to weigh the merits of alternative explanations. So let's take two candidates. One, a crime has been committed. Two, someone's been injured. So maybe somebody just slipped and fell. I mean, we could weigh these two explanations in light of what we see, and then we might say both are plausible, but we're going to pick one of these candidate explanations. So this is one variant of abductive reasoning is something called inference to the best explanation. So it involves abductive reasoning, but abduction and inference to the best explanation are not synonymous, but they're both attempting to do the same thing. They are inferences to interpretations and explanations. And we have to have some criteria, and again, transparent, credible criteria by which we compare two options. So let me take one comparison. Let's say that my two options are homicide and someone's been injured. Which one would I choose out of the two? I think I would go with someone's been injured. I don't think a homicide has occurred here. If there was a dead person somewhere here, I don't think the police would let people just pass by casually like the pedestrians are here. They would have established a perimeter and isolated the area. So I don't think, just on its face, just looking at this picture, I don't think homicide is a likely candidate. Or any crime for that matter. If a crime had been committed, I think that we would not see these civilians, these pedestrians, casually walking by and looking at what's going on. They would be further back. Now, the analogy here is obvious to research. This photograph is analogical to our data. And we look at our data and we're trying to infer explanations and interpretations. And what one person sees in the data is different than what another person sees in the data. So two researchers, well-trained, would look at this and they would likely come up with different kinds of interpretations. Because again, part of this is idiosyncratic, experience-based, and subjective. And this is another really important thing to understand about abductive reasoning, that it has this idiosyncratic cognitive element to it. And when we compare this to induction, induction is more, let's use the term computational. So even though it's not necessarily mathematical, but more formalized. When we make generalizations, generalizations are less subjective than interpretations. This is why the distinction between induction and abduction is so central. How do we evaluate the use of deduction, induction, and abduction? What are the criteria that your audience is going to set on your reasoning as you raised your hand and as you're trying to compel your audience of the credibility of a claim? This is based on Stanovich, 1999, his work on reasoning. This is something Sakumantere and I discuss in the 2013 AMR piece as well. There are three distinct criteria. Criterion number one, you probably learned already in elementary school, in a math class when your teacher told you to show your work, not just the final answer. So what your audience would like to see is what your premises are, what your claim is, what your conclusion is, and then how you bridge your premises to the claim. Simply show your work. So this is the descriptive criterion which really is about transparency of reasoning. Make sure your audience understand how you get from A to B. If you think you can get from A to B using inductive reasoning, show that induction, or at least show how it's possible. Or if you're using deductive reasoning, show that deduction. Anyone who studied math and has proved theorems knows that you really need to show every logical step to show that a proof is valid, because it requires logical deductive coherence. So the descriptive criterion links directly to the type of reasoning that's used. The way we demonstrate a deduction is different from demonstrating induction or abduction. And now, since we're talking about scholarly work and work that produces claims to knowledge, we have to have criteria above and beyond descriptive as we're evaluating the credibility of a claim. So what you need to know is you need to know what the rules are around the table. When we talk about rigor, this is what we're talking about. We're talking about certain prescriptive criteria that your reasoning has to fulfill in order to be accepted by others sitting at the table. This is the prescriptive criterion where you go above and beyond showing your work to showing that your work is rigorous. And finally, there is a normative criterion. Sometimes we use prescriptive and normative synonymously, but it's important to make the distinction here. Normative criteria are often found in the philosophy of science literature. But normative in this meaning doesn't mean things you should do or things that are somehow ethically justified. No, when philosophers of science talk about normative criteria, what they're really doing is they are illuminating what it would take to be certain. So this sounds like very distant to what we do when we go to work Monday morning, but understanding normative criteria is really central in establishing what we might call epistemic humility. Understanding that when we are drawing theoretical conclusions from empirical material, there is something tentative about every claim that we make. And this is because whatever we do in terms of the descriptive and the prescriptive criteria, we never meet the normative ideal. And this is, to me, the most important way in which the philosophy of science literature has been useful to me, not as a source of guidance. When I read Popper or Hempel or others, I don't read their works as handbooks or guidance. They have no guidance to give. But they can give me a couple of important reality checks and indeed are sources of this epistemic humility. So, if you think of the three forms of reasoning, and then you think of these three criteria, what emerges is the 3x3 grid, and I invite you to think about what that grid looks like and how you think about your own reasoning practices in light of the three forms of reasoning and these three criteria. Let me discuss two examples from published research to illustrate the use of reasoning. So I'll use one quantitative, one qualitative example. The quantitative example is this classic make-or-buy study by Walker and Weber that builds on transaction cost economics, organizational economics more generally. We would call this a hypothetical deductive study. I'm going to discuss this label hypothetico-deductive, what it means and why it is probably misleading in that it creates a connotation that deductive reasoning is somehow central or privileged here. Again, that is incorrect. This study, just like any other study, uses all different forms of reasoning. Now, let me start with what the hypothetico-deductive term means. It simply means that as we are formulating our hypotheses, those hypotheses have to be deductively derived from the underlying theory. So that's a notion of hypothetico-deductive. And here's the model from Walker and Weber. This is known as a structural equation model where you have latent variables, the circles, and then your observed variables, the rectangles. And the hypotheses are the arrows connecting the circles, the latent variables, to one another. I'm not going to go into detail on structural equation modeling. It is just like econometric modeling. It is a large sample technique that is used to conduct statistical inference and to test hypotheses using statistical data. Now, why is this not really hypothetico-deductive? Well, if you look at the circles and the rectangles, it's immediately obvious that this is contextualized into the context of automobile final assembly. And indeed, this is the context in which Walker and Weber studied the make-or-buy decision. They looked at a final assembler of automobiles, and they looked at which components and subsystems the final assembler built in-house and which ones they outsourced to external suppliers. So the idea that this model is derived deductively from transaction cost economics simply isn't true. No, transaction cost economics is there. It is a key ingredient, but equally important is the empirical context in which this inquiry takes place. So what the researchers are doing, they're effectively contextualizing or translating transaction cost economics logic into the context of automobile final assembly. Instead of deduction, they're really engaging in abductive reasoning, because that's what contextualization and translation ultimately is about. So if you look at the latent variable supplier competition, for instance, that concept is operationalized using three empirical indicators: competitiveness of quotes, number of suppliers, and supplier proprietary technology. And again, this is a contextualization. When we turn theoretical concepts into empirical measures, what we're doing is the operationalization is not a process of deduction. It is a process of abduction. So there is something fundamentally abductive about the way we turn theories into hypotheses and how we test them. So if we're going to use a reasoning label for this approach, a descriptively more accurate label would be hypothetico-abductive. I don't think anyone uses that term, and I think people are going to keep on using the term hypothetico-deductive or simply hypothesis testing or theory testing research. But I really want to be rigorous with the use of reasoning terminology. To call this hypothetico-deductive in our context, in the context of empirical research on management and organizations, it is misleading. I'm not saying anything about any other fields of research, but in our field, where we operate with theoretical variables that are not directly observable, but they have to be explicitly operationalized into empirical metrics, there's a lot of abduction going on there. Another part of hypothetico-deductive research where abduction is relevant is when a hypothesis is not supported. So I think in this study, there were a number of hypotheses that weren't supported. And when this happens, many quantitative researchers feel compelled to give some kind of reasoning. Why did we not see what we hypothesized to see? Is it because the theory is flawed? Is there something about the data? Is there something about the context that could explain the non-finding? Well, this is, again, characteristically abductive reasoning. You're trying to kind of solve a mystery. Why did I not see what I expected to see? So, as we're trying to figure out why did we not see what we hypothesized to see, it's really detective work. And that detective work involves theoretical considerations, contextual considerations, maybe there's something in the data, and so on. So as we're trying to understand the reasoning processes that take place as we turn theories into hypotheses, test them in statistical samples, and then interpret the results, just to label this hypothetico-deductive without going into detail on the different forms of reasoning that we use throughout, our reasoning simply won't be transparent. Of course, there's plenty of deductive reasoning going on. There's going to be a lot of mathematical calculations going on. Those are deductions. We are going to make empirical inferences from the sample to the population. Those are characteristically inductive. But there are many stages in our reasoning where the reasoning is abductive. So this is one example showing how no matter what your research design, you will use all the three different forms of reasoning. Here's another example. This one's from qualitative research. Disclaimer, I'm not a qualitative researcher myself, but I really want to understand all approaches to empirical research in organization and management research. Because again, no matter what the topic, there are qualitative, quantitative, mixed methods approaches to the topic. So if I'm interested in a topic, I really want to understand all methodological approaches to that topic. Those of you who do qualitative work will recognize this as an application of the Joya methodology. This screenshot is from Joya, Corley, and Hamilton's 2013 piece, but the example is actually from Corley and Joya's 2004 ASQ piece. Just like with the quantitative example, as we're trying to understand how the researchers reasoned, how they got from A to B, we really need to understand the reasoning processes that lead, in the case of Joya methodology, the researchers from the first order concepts to the second order themes, and then on to the aggregate dimensions. And let me take identity ambiguity as an example here. So it appears both as an aggregate dimension and as a second order theme. Let me start with the aggregate dimension. So triggers of identity ambiguity are linked to three second order themes: change in social reference, temporal identity discrepancies, and construed external image discrepancies. Now, what we need to understand is, what are those three arrows? How should we interpret them? What kind of reasoning is embedded in those arrows? Let's see that it's either induction, deduction, or abduction. Let's start with deduction. It can't possibly be deduction. Why? Because deductive reasoning does not allow you to introduce new terms. Ambiguity is not a term that appears in the second order themes. Therefore, the arrows can't be deductive. How about inductive? Is the aggregate dimension a generalization of some kind? I don't think it is. it doesn't generalize. If it did, then we could see it as inductive. To me, it looks more like an interpretation, that they are looking at the second order themes and saying, oh, I think we can interpret this, we can ascribe these to what we call triggers of identity ambiguity. And if it's a sense-making, essentially a translation, then it is more likely to be abductive reasoning. Now, let's look at identity ambiguity as a second order theme where it's driven by 4 different first order concepts. Again, identity ambiguity does not appear in the first order concepts. I think that identity ambiguity is simply the result of a sense-making process. The researchers look at the first order concepts and say, okay, we see identity ambiguity here. My guess is that the term itself comes from the conversation, from the theoretical conversation. Again, these are researchers sitting around a table, and the identity table, if you will, and they are linking their research into that conversation by invoking this term identity ambiguity. But it's not something that's embedded in their data. No, this is more likely, at least in my eyes, this is more likely the result of a sense-making process, a translation of some kind, and that would be abductive, not inductive reasoning. Now, in their 2013 piece, Joya, Corley, and Hamilton write abundantly about inductive reasoning, but they do mention abduction also in that article. And I think that these are instances of abductive reasoning. As the researchers go from the first order to the second order themes and then on to the aggregate dimensions, I think these are sense-making processes. And for the sake of transparency, the others around the table should understand these sense-making processes. Where does identity ambiguity ultimately come from? How is all this informed by the empirical material? And what is the other stuff that is at play here? This is really analogous to the street corner example, where as we're trying to make sense of what happened here, we incorporate information that we don't see in the photograph. Maybe there's some contextual considerations that are brought to bear as we're trying to make sense of what happened on that street corner. I think we have the same thing going on here, that we are, of course, looking at our data. The conclusions are significantly empirically informed, but they're not empirically based as such. Empirical material is central, but it's not something where the second order themes and the aggregate dimensions are somehow embedded and then we just kind of mine them out of the data. No, I don't think that describes the reasoning process accurately. Here's my exercise to you. Think of your own reasoning processes in your own research designs and see if you can spot where you use induction, where you use deduction, where you use abduction, and then see if you can make your reasoning first transparent to yourself and then transparent to your audience. This is a very useful exercise to do. And now for my final reflections of the reasoning session. First of all, just a reality check. Our reasoning is a form of human reasoning. And as a form of human reasoning, our reasoning is subject to all the biases, predispositions, underdetermination fallacies as anyone else's. We have to pay attention to this. We have to be candid about the limits of our reasoning. And when we think of the 3 criteria descriptive, prescriptive, normative. That's a nice antidote to this thinking that we are somehow better reasoners than other human beings, because we're scholars, we're scientists, so we're not subject to the same kinds of frailties and limitations. Well, I hate to break this to you, but we are, just like anyone else. And if you feel compelled to describe your research as inductive, deductive, or abductive, I might just remind you that no matter what label you use, I am absolutely certain that in your research, you use all three forms of reasoning. And I invite you to acknowledge this and then think about how you use these three forms of reasoning and how you make them transparent to your audience. And don't just declare your reasoning, show it. If you think you can get from A to B using deduction, show the deduction. If you think you can get from A to B using induction, show the induction. Start by showing it to yourself. Because sometimes when we reason, we don't necessarily fully understand how we reason. So there may be something tacit about the way we reason, just kind of like there's something tacit about how we ride a bicycle or swinging a swing set or swim, that we observe certain rules without really acknowledging, being aware of applying those rules. So just clarifying your reasoning to yourself can be a useful step here. But of course, ultimately, you want to make sure that your audience understands your reasoning. And one of the things that causes a lot of confusion is the confounding of induction and abduction. I really want to make the distinction clear for you. Please understand the difference between inference from the particular to the general. That's a generalization. That's induction. That's one thing. Another thing is inference to an explanation or an interpretation. Whenever you look at empirical data and make an inference that is not just a generalization, but an interpretation of some kind, you're making sense. You're given an explanation. You are engaging in abductive reasoning. And then finally, this is a lamentation of mine. For the life of me, I don't understand why we invent new meanings for established terminology, most notably induction. Induction has a pretty crisp, well-defined meaning in the philosophy of science literature. And then, of course, there are subcategories of induction, eliminative induction, and enumerative induction. I think we should stick to this terminology instead of inventing new meanings for established terminology. This concludes the presentation of session 2, How Do I Reason?